Hello guys, welcome to calculus class. This time I will try to go over the rest of the questions. Now, question says the table above gives you value of the continuous function f selected value like blah blah blah. Which of the statement is true? So they say it's a continuous function, right? So it's not broken, but it says f has at most 1, 0. So I don't know how graph looks like, but we start from the -5 to 2, and we have a f when this f is -5, y value is -9. So obviously when x is equal to 0, y is 1. So yeah, it's gonna hit here at least once. And then when x equals 2 is the 5, so it can go like that. But is that always true? No. If it says at least 1, 0, yes, this is true. But this can go like this. So this cannot be the answer because it's no. Now, f has a relative maximum at x equals 2. No, this 2 could be minimum, like relative minimum. It does not necessarily have to be a relative maximum, so that cannot be the true. There exists value of c that -5 to 2 such that f of c is equal to 4. Yeah, from here to here, do you see y value is here? Y value is a 5. This is 5, which means at some point here, that should be, you should have a y value of 4. That's a intermediate value theorem, IVT. So yep, this is the answer. And there exists a value of c from such that the slopes are equal to 0. This is a mean value theorem. This is not necessarily true, okay? So answer is going to be C. IVT usually makes sense. MVT is not always, okay? Now, question number 85. The function f as the antiderivative of function g defined by this one. Function f is the antiderivative of g. So function f is the antiderivative of this one. Which of the following is the x-coordinate that locate the local maximum of y f of x? So local maximum means positive to negative, right? That's what you need to do. So what you gotta do is you do you see you gotta do the derivative of the function and then graph it and find positive negative. Only problem is this g of x itself is already f prime of x. Okay, so what you're gonna do is you just put this one into the graph. You just put this into the graph and find the graph that has most positive to negative. Okay, so when you actually put this into the graph, your graph will look like this. You can use decimals because you don't have a calculator. So you have a 2x-intercept, but do you see this is the portion that goes from positive to negative? So your answer is going to be this one. This cannot be the answer because this one is moving negative to positive. Okay, so this point is going to be the minimum. And this one is the maximum. Okay, so this point is x equals 3.14, so it's going to be this. All right. Let's do question number 86 here. So this is a graph of f from 0 to 5. Which of the following could be the graph of f prime of x? So in order to be a prime, it's simple. So let's do this. Do you see 0 to 2 is the positive slope? So 0 to 2 should be in the positive position. So here, positive position, here, positive position, here, positive position. And C is in negative position. This one cannot be the answer. And next, looks like -2 to 3. This one is the negative slope because it's going down. So -2 to 3, it should be in negative slope, negative position. It's in the negative position. This is in the negative position. And this one's the negative slope, but still in the positive position. So this one cannot be the answer. So answer is going to be A or D. And next, from 3 to here, it's going to here like a quadratic, right? So this one cannot be the quadratic because do you remember if it was a quadratic, when you drive it, it becomes 2x, which is a linear. So you're supposed to have a linear graph, so it should be A. Unless this one was a cubic function, then it can go to 2x, 3x squared, which is quadratic, but not in this case, so it's A, okay? It's easy. Now let's look at 87. At this one, velocity of the particle moving x-axis, so that's the velocity. At which time particle change direction from moving left to the right? What is the total distance traveled by particle during the time interval distance? I mean, only thing that you really have to do is you just put this one into the graph. But do you see here, when you're trying to put this one into the graph, like you're trying to, that's the velocity. So if you want to find distance, you're doing the antiderivative from 0 to b, but you cannot really find that one yet. So we gotta find the boundaries. So let's look at this one. First, we gotta put this one into the graph and see, find the, what's that called? Find 0 from 0 to 2. When you put this onto the graph, make sure you put t times sine t to the third power. I mean, actually, like, what's that called? X squared. You gotta put x instead of t, okay? So your boundaries is from 0 to 2, so you're gonna use 0 to 2. Then from the 0 to 2, you're gonna see a very funny graph. You're gonna find something that says like left to right, negative to positive, which is going to be x equals 1.84527. That's what you're going to get when you actually put this one to graph. Let's see if I can actually pull this one out here. So here, let's say x times sine x to the third power. So do you see, make sure your graph is in radian. You're going to have like this graph like that. But you have so many x-intercept here, but you're using 0 to from 0 to 2. Something that says what? Left to the right, negative to positive. So we have 1 for this one, but that's not the case because we're looking for negative to positive. So your answer should be 1.845. Okay? Because question says direction of left to the right, which means negative to positive, right? So it's gonna be from 0 to 1.845. And since we are looking for the distance, remember, it's a distance, you have to use absolute value of t times sine t to the third power dt, okay? Let me move this one. That's what you gotta put into the calculator. Then you're gonna put 1.011. Now, if question was looking for the displacement, then you do not use absolute value. Remember, distance, you use absolute value. Displacement, you don't use absolute value. That's what you have to memorize. Now, question number 88, we have this one. So this is the interval. Now, instantaneous rate of change equal to average rate of change. So what you basically have to do is, first, you're going to find slope. So remember, slope y2 minus y1 over x2 minus x1. So, wow, this is going to be, so this is an interval. That's an x1, that's an x2, not x1, y1. So y2 is going to be, you plug this number into here. So I don't know what that is. I will just write f of 1.565. Just use calculator minus f of 0. Obviously, if you're plugging 0, this y value is going to be 0. Minus 1.565 minus 0. So you just put this one into the calculator. You just put this one in here. Then you're going to get something like, oh, it's 9 o'clock. Something like negative 0.61357 over 1.565. which you're gonna get negative 0.392057. Okay, that's what it is. So that's not the answer because you want to set this one equal to instantaneous rate of change. Average rate of change is the slope. Instantaneous rate of change is the first derivative. So first derivative is you move it x to the third power minus 2x squared. You move it here. Oh, this one works beautifully. X minus 1/2. You just do the derivative here. So if you move 4, 1 over 4 times 4 is just 1. So I just write like that. So, yeah, very simple. You just set them equal to each other. X to the third power minus 2x squared plus x minus 1/2 equal to this one, negative 0.392057. You graph it. You graph and find x-intercept, okay? You're going to have something like this. And obviously, your interval is gonna be something like negative 0 point, like it's gonna be like you're gonna have like 3 intersection point here, okay? So it's gonna be 3. We have 2 more questions, but looks like I'm running out of time, so I'm gonna make the maybe third video for 2 questions. All right, that's about it. See you in the next video. Bye.